Good morning. My name is Marco Rubio, and this project is called Traffic Accident Data Analysis using MongoDB and Python. The goal of this project was to analyze a large traffic accident data set using Python and MongoDB as a non-SQL database solution. The project focused on data storage, query execution, benchmarking, and data visualization. For this project, I used the US accident dataset downloaded from Kaggle. The dataset contains information about road accidents recorded between 2016 and 2023. It includes details such as accident severity, city, state, weather condition, timestamp, and road information. I select this data because it contains a large amount of real-world data suitable for non-SQL processing and benchmarking. Since the dataset was large, it was useful for testing database performance and query execution. To complete the project, I used Python together with MongoDB. Python was used to process and import the CSV dataset, while MongoDB was used to store and retrieve the data. You can see here we have our MongoDB with our traffic accident data, and we can see that it has over 5,000 documents. In the architecture diagram, the workflow of the project is shown step by step. We have here the diagram architecture. The CSV dataset was first processed using Python input script. After that, the data was stored inside a MongoDB database called Traffic Accident DB. Then another Python script was used to execute NoSQL queries on the database. Additional scripts were created for benchmarking and visualization. Finally, the results were used to create charts and analysis for the poster. The three NoSQL queries were created during this project. You can see them here. The first query filtered accident records from the state of Ohio. This query was similar to SQL word class. We have it here. The second query grouped accident records by severity level to calculate the total number of accidents in each category. This demonstrates grouping and aggregation operations in MongoDB. The third query sorted the city by the highest number of accidents and returned the top 5 cities with the most recorded incidents. These queries demonstrate the use of filtering, grouping, and sorting operations in a NoSQL database environment. This project also includes performance benchmarking. The benchmark testing was complete using MongoDB query execution times on a dataset containing 5,000 accident records. Two workloads were tested. We have here the performance benchmark results. Two workloads were tested. The first benchmark tested a filtering query based on accident location. The second benchmark test an aggregation query used to retrieve the cities with the highest number of accidents. The results show that MongoDB processed both queries very quickly and efficiently. Execution times were measured in seconds and demonstrate good database performance when handling large databases. The visualization chart showed the top 5 cities with the highest number of accidents. We have here the table. I couldn't put it on the poster, but I have it here on my DS console. The visualization chart shows the top 5 cities with the highest number of accidents in the selected dataset. Sacramento recorded the highest number of accidents, followed by Dayton and San Jose. You can see here Oakland is the least city with accidents. This graph helps demonstrate how accident frequency differs between cities and how MongoDB data can be converted into visual results for analysis and presentation. One challenge encountered during the project was handling a large dataset and correctly importing the data into MongoDB. Additional issues included file path errors, organizing complex files, and ensuring MongoDB connections work correctly. These problems were solved through testing, debugging, and adjustment to the Python script during development. Overall, this project demonstrates how MongoDB and Python can be used together for a large-scale data storage, NoSQL query execution, benchmarking, and visualization. Thank you for listening.